Welcome to the next session of subject engineering maths. We were in chapter 3 discussing differential calculus of calculus module. In the last session, we have finished two mean value theorems. One is Lagrange's mean value theorem and second one is Rolle's mean value theorem, right? In fact, Rolle's mean value theorem is a particular case of Lagrange's mean value theorem because we have seen f of a equal to f of b. Then that Lagrange's mean value theorem becomes exactly Rolle's mean value theorem. Okay, if it is Lagrange's mean value theorem, f of a is not equal to f of b. If f of a and f of b are same, then this is called Rolle's mean value theorem, right? Now we discuss next mean value theorem, that is called Cauchy's mean value theorem. So third mean value theorem is Cauchy's mean value theorem. Let us see what it states. Suppose we have two functions f of x comma g of x. Both have domain closed interval a comma b and it is defined to set of real numbers, and even the second function again has same domain and same codomain. Domain and codomain are a comma b and r. So assume that these two functions are satisfy three conditions. The first condition is f of x comma g of x are continuous in closed interval a comma b. So just like continuity in case of Lagrange's and Rolle's mean value theorems, both are continuous in the same interval a comma b and both are differentiable in open interval a comma b. Differentiable in open interval a comma b, and the third condition we have is g dash of x is not equal to 0 for all x belongs to open interval a comma b. This is one important condition. So derivative of g should not be 0 for all x belong to this. When you look at the first two conditions, what are they? Both are continuous in same interval a comma b and both are differentiable in same interval open interval a comma b. So when you try to apply Lagrange's mean value theorem separately for f of x and g of x, then my conclusion becomes like this. So when I am going to apply Lagrange's mean value theorem for f of x in this interval, because of this continuity and this differentiability, f dash of c becomes f of b minus f of a divided by b minus a by Lagrange's mean value theorem. If I apply Lagrange's theorem for g of x, then my conclusion will be like this: g dash of c equal to g of b minus g of a divided by b minus a. Now let us combine these two. I will get this. There exists c belongs to open interval a comma b such that f dash of c by g dash of c equal to, so divide this quantity with this. So when you get b minus a, b minus will be cancelled, so that this expression becomes f of b minus f of a divided by g of b minus g of a. Now this is the conclusion of Cauchy's mean value theorem. Now since g dash of c is written in the denominator part, it should not be 0. So we don't know what is the value of c, but we have some information about c. C will be very close to mean value, but we don't know exactly what it is. If it is a second degree polynomial expression, c is always midpoint. If it is not a second degree polynomial expression, sometimes you are getting c value, mean value, sometimes it is close to mean value. See, something is close to mean means we cannot predict also. It is somehow close, but it changes from example to example. So for safety measurement, what we were taking is, we were taking g dash of x not equal to 0 for all x belong to a comma b. So therefore, since g dash of c is written in the denominator, it should not be 0. Therefore, as a safety measurement, let us take g dash of x not equal to 0 for all x belong to this. Therefore, whenever two functions satisfy these three conditions, then at least at one point c in open interval a comma b, this will happen. So how we are getting this conclusion? This is basically an application of Lagrange's mean value theorem for two different functions f of x and g of x defined in same interval. Got it? See, when you go through all these mean value theorems, the basic point is Lagrange's mean value theorem. At least at one point C, f dash of C is f of b minus f of a by b minus a. In case of Rolle's theorem, since function takes same values at the endpoints, f dash of C is becoming 0. Now in this case, we were applying mean value theorem, Lagrange's mean value theorem for two different functions defined in same closed interval a comma b. Therefore, when you go through all these mean value theorems, it clearly indicates us the Lagrange's mean value theorem is most basic mean value theorem. Okay. So in the examination, if they do not specify the name of mean value theorem, then how to get answer? If the name of the mean value theorem is not specified in the examination, if two functions are given, then it refers to Cauchy's mean value theorem. If only single function is given, it can be either Lagrange's or Rolle's theorem. If f of a equal to f of b, it comes under Rolle's theorem. Otherwise, it is Lagrange's theorem. So you need not require the name of mean value theorem during questions. Okay. So note this point. Let f from closed interval a comma b to r. Let f from closed interval a b to r, comma g from closed interval a b to r, g from closed interval a b to r be two functions such that point number 1, f of x comma g of x are continuous in closed interval a comma b. F of x comma g of x are continuous in closed interval a comma b. Second condition, f of x comma g of x are differentiable in open interval a comma b. F of x comma g of x are differentiable in open interval a comma b. Third condition, g dash of x not equal to 0 for all x belongs to closed interval a comma b. G dash of x not equal to 0 for all x belong to open interval a comma b. Then at least at one point, say C in open interval a comma b, then at least at one point say C in open interval a comma b, comma f dash of C by g dash of C, f dash of C by g dash of C equal to f of b minus f of a by g of b minus g of a. Highlight this point. Hope you understand this. Note, Cauchy's mean value theorem is a simple application of Lagrange's mean value theorem. Cauchy's mean value theorem is a simple application of Lagrange's mean value theorem for two different functions defined in same interval. Cauchy's mean value theorem is a simple application of Lagrange's mean value theorem for two different functions defined in same interval. Right? Now let us discuss one example on this mean value theorem. Suppose we have f of x equal to x square, g of x equal to x cube. So assume that the interval is 2, 3. So we need to verify Cauchy's mean value theorem for two different functions f of x and g of x in this interval. Let us see, both are polynomial expressions. So both are continuous in this interval. So f of x comma g of x are continuous in closed interval 2 comma 3 or continuous in closed interval 2 comma 3, and both are differentiable in open interval a comma b. Both are differentiable in open interval a comma b, that is 2 comma 3. Now let us verify third condition. What is g dash of x? This is 3x square. This becomes 0 only when x is 0, but 0 is not a member of this interval. Therefore, this is a non-zero expression for all x belongs to open interval 2 comma 3. Therefore, these two functions met the requirements of Cauchy's mean value theorem. These two functions are fulfilled the requirements of Cauchy's mean value theorem. Therefore, by Cauchy's mean value theorem, by CMVT, Cauchy's mean value theorem, there exists C belong to open interval 2 comma 3 such that f dash of C by g dash of C equal to f of 3 minus f of 2 divided by g of 3 minus g of 2. So this, therefore, f dash of C, derivative of this 2x, but at C the derivative is 2c. G dash of C is 3c square. F of 3, this is 9, f of 2 4 divided by g of 3 27 minus 8. So this implies 2 by 3c equal to this is 5 by 19. So therefore this implies this is 18 equal to 2 times 19, this is 38. 38 equal to, cross multiply this, you will get 15c. Therefore this implies c equal to 38 by 15. So 15 2's 30, so 2 point something. So this will be 2 point something. So c value is like this. So approximately this will be 2 point something. Now we can cross check this. Anyhow, this will be close to this mean of this interval. Approximately this can be 5 approximately. So note down this point. Now we start class 2 workbook. The questions based on limits concept, continuity, differentiable functions followed by mean value theorems. Just open your class 2 workbook. Let us start class 2 workbook with question number 1. What it is? Limit extends to 4 x cube minus 64 divided by log of x minus 3 to the base e. So we need to find out this. Options are given as 24, 48, 72, 96. Let us calculate this limit. Replace x by 4, it will be 0 numerator. Even replace x by 4 log 1. Log 1 to the base e is 0. So when you replace x by 4, it is in the form 0 by 0. Now apply L'Hospital rule. So when you apply L'Hospital rule, this particular limit must be equal to, limit extends to 4. Apply the derivative of this only numerator function, because when you replace x by 4, we are getting 0 by 0 form. Apply L'Hospital rule. Derivative of numerator is 3x square. Derivative of denominator 1 by x minus 3. Now replace x by 4. So this is 3 into 4 square divided by 1 by 4 minus 3. So therefore this is 48. So 3 into 16, the result is 48. So option B is right answer. Note this. Limit extends to 0. Log of 1 plus 4x to the base e divided by e power 3x minus 1. Now replace x by 0, it becomes log 1. Log 1 is 0. Replace x by 0, e power 0, 1, 1 minus 1, 0. So again it is in 0 by 0 form. Now apply L'Hospital rule. This limit must be equal to, limit extends to 0. Derivative of this log x, it is in the form log x. So 1 by 1 plus 4x into 1 plus 4x derivative is 4 divided by the derivative of denominator is 3 into e power 3x. Now replace x by 0. The result is 4 by 3. So option number C. Option C is right answer. We move to question number 3. Limit x tends to 9. Square root of x minus 3 divided by x square minus 81. Let us try to find this limit. Question number 3. Replace x by 9, square root of 9, 3. 3 minus 3 is 0. 9 square 81. 81 minus 81, 0. Again it is in 0 by 0 form. Therefore, when you apply L'Hospital rule, this result will be equal to limit x tends to 9. The derivative of this 1 by 2 root x divided by derivative of this is 2x. So therefore this is nothing but limit x tends to 9. This is 1 by 4 times root x into x power 3 by 2. Now replace x by 9. This is 1 by 4 into 9 power 3 by 2. So therefore this is 1 by 4 into this 9, we can write it as 3 square. So 3 square whole power 3 by 2. This 2 will be cancelled. So this is 1 by 4 into 3 cube is 27. So therefore this is 1 by 108. 1 by 108. So option C is right answer. Limit alpha tends to 0. X power alpha minus 1 by alpha is options are given. Now let us try to find this. Here x is not variable. Generally people may think like that when x is variable, then when they go for differentiation this alpha into x power alpha minus 1, when they replace x by 0, the result will be 0. But here the variable is alpha, x is constant because alpha is approaching 0. So here alpha is a variable quantity and x is a constant quantity. X is a constant. So replace alpha by 0. X power 0 is 1. 1 minus 1, 0. 0 by 0 form. So apply L'Hospital rule. Limit alpha tends to 0. Now this is constant, this is variable. Just like this, so d by dx of a power x. What is the derivative of a power x? A power x into log a. Now here in place of a we have x, in place of alpha this. So this is constant, this is variable. So therefore derivative of numerator is x power alpha into log x divided by derivative of alpha with respect to alpha, because we were finding derivative with respect to alpha since alpha is a variable. Now replace alpha by 0 because this is a constant expression. So it can be taken before log. Log x into x power 0, it is 1. So the result is log x. So option number A is right answer. Option A is right answer. This is limit x tends to infinity. X into tan 1 by x. Options are given. Now here x is infinity. So people may think like this. Replace x by infinity. Infinity into 1 by infinity is 0. Now this is a tan 0. Tan 0 is 0. Infinity into 0 is 0. This is wrong. Because infinity into 0 is indeterminate form. We cannot measure. Indeterminate form. Unfortunately, 0 is one of the option. 0 is one of the option. So don't try to attempt like this, because infinity, anything into 0 is 0, provided anything is a finite number. Here infinity is not a number. It's a symbol that to represent a finite, a non-finite number. So therefore in this case we were getting infinity into 0, that is non-zero, indeterminate form. But even don't think that indeterminate form is equal to infinity, because even infinity is one of the options. Okay. So therefore let us try to find out this. So here as x tends to infinity implies 1 by x tends to 0. So here I take p equal to 1 by x. Therefore, as x tends to infinity, whenever x is reaching to infinity, 1 by x is slowly reaching to 0. I assume that 1 by x is p. Therefore, this limit will be equivalent to limit x tends to, not x tends to infinity. So, p tends to 0. This is a tan 1 by x is p. This numerator x I can write it as 1 by x, but I can write it as p. Because when p is 1 by x, x is 1 by p. When p is x, x equal to 1 by p. So therefore, this is in the form limit p tends to 0 tan p by p. Now replace p by 0, 0 by 0 form. Apply L'Hospital rule. Now p is a variable. So derivative of tan p, secant square p, derivative of p is 1. Now therefore, secant square 0 is 1. Therefore, 1 is right answer. So option B is a correct option. The value of k for which the function defined below is continuous at 1. Let us write the function. Here the function f of x is 2x plus kx square if x is less than or equal to 1. 4x plus 3 if x is greater than 1. So we need to find the value of k for which this function is continuous at 1. Here f of x is given as continuous at 1. This is a function which is continuous at x equal to 1. What does it mean? Limit x tends to 1, f of x must exist and this value must be equal to functional value. This is a finite number. So limit x tends to 1, f of x must be exist. It's a finite number and this finite number must be equal to f of 1. What does it mean? At first, if you want to say that limit value exists, LHL must be equal to RHL. LHL must be equal to RHL. When you look at the functions, when x less than 1, this is the function. When x is greater than 1, this is the function. So for LHL, this is the function. For right side, this is the function. So let us find LHL value. So here LHL value is limit x tends to 1 minus f of x. RHL is limit x tends to 1 plus f of x. Therefore, this is limit x tends to 1. For LHL, because x tends to 1 minus means x less than 1. When x is less than 1, this is the function. So this is limit x tends to 1, 2x plus kx square equal to limit x tends to 1. 1 plus means x greater than 1. When x is greater than 1, this is the function. So it is 4x plus 3. Now replace x by 1, we get 2 plus k equal to replace x by 1, we get 7. Therefore, k value equal to 5. Therefore, option C is right answer. Now this point. Question number 7. The values of x for which the function f of x equal to x square minus 3x minus 4 divided by x square plus 3x minus 4 is not continuous. Now we need to find the values of x where this function is not continuous. It is a rational expression because it is in the form of a fraction. When you go to numbers, we discuss 2 by 3, 5 by 6 like this. Now this is a p of x by, for example, q of x, rational expression. Now this is a polynomial expression. It is always continuous. Even when you look at x square plus 3x minus 4 separately, it is continuous. So you don't get any discontinuity points for polynomial expressions. But here this is written in the denominator part. So make the denominator equal to 0 at those points, the overall function becomes discontinuous. Not continuous means discontinuous. So make this denominator equal to 0. X square plus 3x minus 4 equal to 0. This implies x plus 4 into factorization, x minus 1 equal to 0. Now this implies x values are minus 1, 1. So at these points only the function is not continuous, minus 4, 1. So option C is right. Question number 8. Which of the following functions is not differentiable in the domain closed interval -1 comma +1? Let us see options. First option is x square. It is a polynomial expression. Second one is x minus 1. It is a polynomial expression. Third one is 2. It is a constant function. We know that all constant functions and polynomials are differentiable in all domains. So in particular, this x square, x minus 1 and 2, option A, B and C, all these are differentiable in closed interval -1 comma 1. Therefore, option D is right answer. Right? So for question number 8, option D is right answer. Because in the first option we have x square. In B we have x minus 1. In C we have 2. In D it is maximum of x comma minus x. We know that this is a polynomial expression, constant function. All these are differentiable in the domain closed interval -1 comma 1. Therefore, this is the only function which is not differentiable in this. Therefore, this is the required answer. All these are differentiable in closed interval -1 comma +1. So ultimately, this is a function which is not differentiable. So D is required answer. See, for this question we got answer in the indirect way because first three options are not right options. So ultimately D is right answer. Option A can be eliminated, B can be eliminated, even C can be eliminated. Therefore D is right answer because this is the function which is not differentiable. But how it is not differentiable in closed interval -1 comma 1? Let us see. Here, what is modulus of x? This is x when x is non-negative, minus x if x is less than 0. Therefore, this overall function I can write it as maximum of x comma minus x. Try to understand this. Mod x is also equivalent to maximum of x comma minus x. Let me give you one example. Suppose I have modulus of 2. Actually, modulus of 2 is 2. This 2 I can write it as maximum of 2 comma minus 2. Similarly, if I have modulus of -2, I can write it as 2. This 2 is nothing but maximum of, original value is -2, minus of -2. So modulus of -2 is 2. I can write this as maximum of x comma minus x. Therefore, mod x is maximum of x comma minus x. But mod x is nothing but mod x minus 0. Now it is in the form mod x minus k. Therefore, whenever we have a function modulus of x minus k, it is differentiable at all points except at k. So what is the drawback of this function regarding 0 or derivative? 0. And 0 belongs to this interval. 0 belongs to closed interval -1 comma 1. So if a function has no derivative at least one point in closed interval a comma b, ultimately it is not differentiable because one drawback is enough. And what is the drawback of this function? 0, and 0 belongs to this interval. Therefore, this is the function which is not differentiable in this domain. Okay, work out this. Number 9. What should be the value of lambda such that the function defined below is continuous at x equal to pi by 2? So a function is given. Of course, it has two forms. One is lambda cos x by pi by 2 minus x if x not equal to pi by 2. If x is pi by 2, it is 1. So function has multiple forms. Now let us see what should be the value of lambda for which this is continuous at x equal to pi by 2. Let me write out the function at first. Here f of x equal to lambda cos x divided by pi by 2 minus x if x is not equal to pi by 2. This is 1 if x is pi by 2. Now we need to find the value of lambda for which this is continuous at pi by 2. It is given that f of x is continuous at pi by 2. Continuous at x equal to pi by 2. Now since it is continuous at pi by 2, limit x tends to pi by 2, f of x equal to f of pi by 2. Limit x tends to pi by 2, f of x equal to pi by 2. Here function takes multiple forms, but in this case it is not required to evaluate both LHL and RHL. Why? Here x is not equal to pi by 2. That means when x is less than pi by 2 as well as when x is greater than pi by 2, the function is this lambda cos x by pi by 2 minus x. So generally when x is less than pi by 2, we can discuss left hand limit. When x is greater than pi by 2, we can go for right hand limit. But here for both LHL and RHL, the function is same. So you need not calculate LHL and RHL. Even if you calculate, you will get the same. So let us calculate limits. This implies limit x tends to pi by 2. The function f of x is lambda cos x divided by pi by 2 minus x equal to f of pi by 2. Replace x by pi by 2, it is 1. Now replace x by 90 degrees. So therefore this is in the form cos 90 0, 0 by 0 form. Apply L'Hospital rule. The derivative of lambda cos x is minus lambda sin x divided by its derivative minus 1 equal to 1. Now replace x by pi by 2, sin 90 is 1. Therefore the value of lambda is 1. So when you apply just definition of continuous function followed by application of L'Hospital rule, we were getting lambda value equal to 1. So option C is right answer. Note this. 10. The function f of x equal to a0 plus a1 mod x plus a2 mod x whole square plus a3 mod x whole cube is differentiable at x equal to 0. It is given that this function is differentiable at x equal to 0. Options are like this. For no values of a0, a1, a2, a3, all these are constants. a0 is a constant, a1 constant, a2 constant, a3 constant. So continue the question, read the question along with options. The function f of x equal to this is differentiable at x equal to 0. Option A, for no values of a0, a1, a2, a3. What does it mean? It is not differentiable at x equal to 0 for any values generally. That means it is not differentiable. Option B, for any values of a0, a1, a2, a3. In the first option, even if you give any values of a0, a1, a2, a3, it is not differentiable. In option B, it is exactly opposite. For all values of a0, a1, a2, a3, it is differentiable at x equal to 0. Option C, only if a1 is 0. Option D, only if a1 is 0 and a3 is 0. Look at this. Generally, people may think like this. Here, this is not differentiable. X is not differentiable at x is 0. So, generally, people may think that if a1 is 0 and a3 is 0, then anyhow this mod x square becomes x square only, because mod x is plus or minus x. So, it becomes still a2 x square only. So, when a1 is 0 and a3 is 0, the function becomes like this. a0 plus a2 x square only. Then it is differentiable at x equal to 0. So people may think like this, but let us work out this. So let us redefine this function f of x equal to what when x is non-negative. F of x is what when x is negative. So I am going to redefine this function. When the problem questions are given like this, try to redefine the function. When x is greater than or equal to 0, this mod x becomes x. Therefore, this becomes a0 plus a1 x plus a2 x square plus a3 x cube. Because when x is greater than or equal to 0, mod x becomes x. When x is less than 0, mod x becomes minus x. So this becomes a0 minus a1 x plus a2 x square minus a3 x cube. Since the function takes two different forms, above 0 one function and below 0 one function. So in that case, we need to find left hand and right hand derivatives. So let us find the derivative. F dash of x equal to, let us find its derivative, a1 plus 2a2x plus 3a3x square if x is greater than or equal to 0. Now this one is minus a1 plus 2a2x minus 3a3x square if x is less than 0. Now this is the function for right derivative and this is the function for left derivative. Since f of x is differentiable at x equal to 0 implies LHD must be equal to RHD. LHD must be equal to RHD. Now we were discussing derivative at 0. This is the function for right hand derivative, function for left hand derivative. But we need to find derivative at 0. So replace x by 0 here and x by 0. This is LHD. Replace x by 0, we get minus a1. And replace x value 0, you will get right hand derivative, it is a1. So this implies 2a1 equal to 0. Therefore, a1 equal to 0. Therefore, the function f of x is differentiable at x equal to 0 only if a1 is 0. Only if a1 is 0. Therefore, option number C is right. Option C is right answer. Note this. Next question. 11. Question number 11. Which of the following functions is continuous at x equal to 3? Let us verify options one by one. Option A is this, f of x equal to 2 if x equal to 3. X minus 1 if x is greater than 3. X plus 3 by 3 if x is less than 3. Let us verify first option. Which of the following is continuous at x equal to 3? See, if you want to say that it is continuous at 3, LHL must be equal to f of 3. RHL must be equal to f of 3. And f of 3 is a finite quantity. It is a finite number. Now you can see this is the function for LHL. So here LHL value equal to, replace x by 3, 3 plus 3, 6 by 3, 2. Now RHL value, for right side this is the function, replace x by 3, 3 minus 1, 2. Now what is f of 3, replace x by 3, f of 3 equal to 2. So therefore LHL value is 2, RHL value equal to 2. So limit value exists, both are finite numbers and exist, and that is equal to functional value. Therefore in this case what happened is, limit x tends to 3, f of x is finite value and this is equal to f of 3. Therefore the option A is a function which is continuous at x equal to 3. Even you can verify option B. For option B, limit value equal to, that is limit x tends to 3, f of x equal to, actually when x not equal to 3 the function is 8 minus x. So replace x by 3, you will get 5. But what is f of 3? F of 3 is 4. So this and this are different numbers. So this is not a continuous function. Limit value is 5, but that is not matching with the functional value. In option C, what is LHL value? LHL value equal to 3 plus 3, 6. Because the function is x plus 3. For RHL, the function is x minus 4. So it is minus 1. So limit does not exist at first. When you look at option D, so it is not right answer because f of 3 is not given. When f of 3 is not given, so how can you confirm that this is continuous? So therefore option B is wrong answer, C is wrong answer, D anyhow we got option A is continuous because LHL value 2, RHL 2, f of 3 is 2. So limit LHL value, RHL value both are same. So limit is getting exists and that is equal to functional value. So this is an example where it is continuous at 3. So option A is right answer. Note this.